So we're in the packet still, but now we're on the multiple forces one. So if we've got a soccer ball, for lack of a better term, okay? If we have a ball or anything, or pretty much anything, if we have that, what's going to happen if I apply a force to that? What's going to happen to that ball? It's going to go that way, right? And how much force I apply to it is going to determine how far it goes, right? So how much force that we apply to it would be the magnitude, okay? And the direction that it's going to go is going to depend on the direction that we're applying the force, okay? What happens now if, oops, that way, thank you. Oh, no problem. Oops, I went the wrong way. I'll have to move this one. What happens now, oops, move the whole ball. Come on, there we go. If I apply another force going the opposite direction. Depends on the magnitude of the forces, right? Okay. If the magnitudes are equal, what's going to happen to the ball? Nothing, it won't move. If one of them's more, then it's going to move in that towards the opposite direction kind of deal, right? Okay. What happens if they're not countering each other? Make this be a little bit bigger. What happens if they're not countering each other? It's going to kind of go, it's going to have an end result, right? So if this was the case, so which way, I'll go counter or I'll go clockwise, based off of this scenario, which way do you think the ball is going to move? Tell me when to stop. Ooh, we're going to go around again. Somewhere in here? Okay, all right. So the ball is going to go somewhere in like that direction. Okay, that's going to be our we call that the resultant force. Okay, it's going to be the direction and the magnitude is going to depend on the factors going into it. Okay? So when we have multiple forces enacting on an object, okay, we're going to find the vectors we're going to find the vector of the first force. Then we're going to find the vector of the second force. Oops, not. And what are we going to do with those two vectors? Say it loud. We're going to add them together. And the resultant force is going to be all the vectors added together. Okay? That's going to be our resultant force. So remembering from yesterday how we find a vector given a magnitude and a direction, we take the magnitude times the cosine of the direction. That gives us our horizontal component. We take the magnitude times the sine of the direction. That gives us our vertical component. Okay? And then we add all those together from all those different forces. Okay? Let's try one. Okay? So a force of 50 pounds acts on an object at an angle of 45 degrees. A second force of 75 pounds acts on the object at an angle of negative 60 degrees. Find the direction and magnitude of the resultant force. Okay? So we've got force number 1 would be, the vector would be 50, that's the magnitude of it, times the cosine of 45 degrees. And 50 times the sine of 45 degrees. Yes? Okay. Cosine at 45. Root 2 over 2, right? Okay. 50 times root 2 over 2 then is going to be 25 square roots of 2. Yes? Sine at 45 degrees? Root 2 over 2 again? Yep. So that's 25 square roots of 2 again. Okay. Then we've got force number 2. This one now has a 75 magnitude, and it's acting on a cosine of negative 60 degrees. Negative 60 degrees is also what? .300 degrees, right? Okay. So the cosine at negative 60 degrees is 1/2. Okay. So then this is going to be 75 over 2. The sine at negative 60 degrees is negative root 3 over 2. So then that's going to be 75 square roots of 3. Oops, I forgot the negative sign. All over 2. Yes? Yeah? Okay. So the resultant force is going to be those all added together. My glasses on so I can actually see something here. 25 square roots of 2 plus 70. So I put that in parentheses. 75 divided by 2 gets me. So my result $72.85534 and square roots of 3 and divided by 2. Ooh, come on. I don't like that. Why can't you give it to me in? Why can't you give it to me in? Mine didn't like it. It gave it to me in as a radical. Negative, back me up on this, 29.5965. I went 7. Yes? Yeah? Okay. Now I need the direction and the magnitude of that. How am I going to find those? Inverse tangent, drop the signs. Okay. I get a reference angle here of 22.10883 degrees. Yes? Which quadrant is this vector in, though? Which one? 4. Positive, negative quadrant is quadrant 4. Okay, so how do I find actual theta? 360 minus that. I get 337.891 degrees for my resultant direction. Okay, how do I find the magnitude? Spoons and boats and stuff are here, up here, and in the back. How do I find the magnitude? I have to do that what? Which equation is it? Square them, and I do something else first too. Square them and add them together first. Then, yep. Let's see, 72.8554 squared plus 59657 squared is 6183552. I get here that it is 78.638 and the label was pounds. Yes? Okay. Handle, or you want me to do one more? Like, do you think you can handle one on your own right now? We're gonna do one more no matter what you think you want. I think you should try it on your own first, then I'll go through it. Okay? So it's a 3/4 one. Go for it. There's some. Okay, so then this one's going to be cosine of -30, so that's going to be √3/2, so that's going to be 35 square roots of 2. -30 is -1/2, that's going to be -35. This one's going to be 20. Oops, hold on. This shouldn't be square root of 2. That should be square root of 3. That should be a square root of 3. It's going to be 135 is so my result.
Sorry. I didn't get it right.
Oh, that's going to be 35 square roots of 3 minus 10 square roots of 2. And then this is going to be negative 35 plus 50 square roots of 2. So then this is going to be 35 square roots of 3 minus 10 square roots of 2. And I'm going to store that as my A. And it's going to be 46.4796. And then we have negative 35 plus 50 square roots of 2. That's going to be my B. That's going to be 35.7107. Clement. Plates and silverware are up here. There's fresh. These pies up here are from the kids in the room here, and then the ones in the back are from earlier in the day. Yep. Eat.
They're all the MVPs for bringing pies.
Yep. Nope, that's okay. They're doing this problem already, so I'm just finishing it off for them. I get a magnitude here of 58.614 pounds. Yes, 58.614, and I get a direction angle of E divided by K. Escape. Inverse tangent of that gets me 37.535 degrees because it's in quadrant number 1. Have a good day.